Hi folks, we're going to take a look at 8A from page 553. So they want us to solve this system of equations. So here again, first thing you should always do is look for any parallel planes. And here 1 and 2 definitely are not, 2 and 3 are not. But if I look at 1 and 3, I notice that looks like these things are parallel. Because if I take N1, okay, that's 3, 4, 1. And then N3 is 6, 8, 2. And that's just equal to 2 times N1. Okay, so we know that they're parallel. Question is are they parallel and coincident, or are they parallel and distinct? So here we have to look at the D values, and I see that D3 is also equal to 2 times D1. So that means that 1 and 3 are coincident. So essentially it means I'm really finding the intersection of two planes, because here this one is not parallel, so I must have this scenario where I've got, sort of two that are the same and another one that crosses it. Whoops, sorry, there you go. So we know that the intersection will be a line coming out of the page. Okay, so I really only have to work with two equations since these two are equivalent. So let's work with 1 and 2. So here what I need to do is I need to eliminate one of my variables. So here, I guess eliminating the y's looks like, like it works. So I'm going to do equation 1 minus 2 times equation 2. Okay? So let's say what we have. We have 3 minus 10, so that's going to be negative 7. It's going to be negative 7x. Here, what do we have? We have 4 minus 4, so 0. Good, we eliminated the y. And here we have 1 minus 6 is negative 5, so negative 5z is equal to 4 minus 2 times 2, 4, 0. Okay, that makes life a little easier. Okay, and so now what we've done is we've created an equation that involves x and z, and the deal here is to write one variable in terms of the other. So I don't know, I'll solve for z here. I guess dividing by 5 is a little nicer than dividing by 7. So negative 5z is equal to 7x. So z is equal to negative 7 over 5x. Okay? So in order to find the equation of the line of intersection, I'm going to write y in terms of x. Okay? So I'm going to pick one of those two equations. I guess, I don't know, I guess number 2 looks a little better. Either one's pretty ugly. So let's take equation 2. So what do we have? We have 5x, okay, plus 2y, and then plus 3 times z, which is negative 7 over 5x from before, is equal to 2. Okay. So here, let's, I guess I'll put everything over 5, at least for this one here. So this will be 25 over 5x plus 2y. This is going to be minus 21 over 5x equals 2. Okay, so 2y equals, so let's do this here. So 25 minus 21 is 4 over 5. So bring it to the other side. It'll be negative 4 over 5x plus 2, and now let's divide that by 2. So here we have negative 4 over 10 x plus 1, which of course is just negative 2/5 x plus 1. Okay, so what we've managed to do is to write both z and y in terms of x, and so x now becomes our parameter. So let x equals t. So our equation is going to be x equals t, y equals negative 2/5 t plus 1, and z is going to be equal to, where was z? Negative 7/5 t. And here t takes on all real numbers. Okay, and there's the equation of our line. Okay, so depending on what you would have chosen to first of all eliminate and what you chose to write in terms of will make your equation look different. I guess one test would be to check that the direction vectors, okay, whatever form you have, should always be parallel. And if they are, chances are you got the right answer. Okay, so just to recap here, step number one was to realize that two of these planes were actually parallel and coincident, okay, and the other one not being parallel told us that we were going to have the equation of a line as our answer, okay. And then from there, it's the usual: eliminate a variable and write both two variables in terms of a third, and that third becomes your parameter. Okay, that's it for this one.